All right. Hi, my name is Doug Cluck. I work for the National Oceanic and Atmospheric Administration based out of Kansas City, Missouri. And today is the next in the series of monthly North Central U.S. climate and drought outlooks. Obviously for January, New Year, 2024. Our speaker today is Jerry Brodsky from the Kentucky Climate Center. He's the state climatologist there in Kentucky. And some of you may remember his predecessor, Stu Foster, who has done this too over the years. But Jerry's relatively new, we'll say. And so he's going to give us our outlook today. A couple things to remember are that at the end of the presentation, we'll do a Q&A session. If you have comments or questions, put them into the question interface. We don't use the chat so much, so just use the question interface to get your point or question in there. We'll try to get to it at the end. Occasionally we go over time, but that's okay. We have nothing else to do. We'll answer your questions. Just kidding on the nothing else to do part. So without any further ado, Jerry, why don't you take it away, and thank you very much for doing this.
Now, thank you, Doug, and welcome everyone. And just a few, some general information to get started. This is provided. This is in collaboration with a number of climate services across the U.S., including the various NOAA agencies, USDA climate hubs, American Association of State Climatologists, the Midwest and High Plains Regional Climate Centers, and the National Drought Mitigation Center. And the next regular Climate Drought Outlook webinar is fairly early next month. It's February 15th at 1 p.m. Central Time, and that speaker will be Matt Sattel from the Kansas Climate Office, who is also relatively new to speaking to this group. And if you're interested in past webinars, they are available at both the Midwest and High Plains Regional Climate Centers. And as Doug said, we'll be open for questions at the end of this presentation. So we have a lot to get to, being that it's the beginning of new year. So we'll start off with a recap of both last year and last month. And we'll look at this month so far, which has been fairly active. And then we'll look at the impacts of those, the impact of ongoing drought in some areas, the recent snow and cold, and some other various issues. And then we'll end this by looking at the outlooks, both with El Nino and then the rest of this winter. And then we'll take a look at drought and what that looks like going forward. So let's get started. So we'll kick off by looking at last year, and I've summed it up by calling it warm and dry, which is mostly true depending on where you live. So all of last year was very hot in most areas. Over half the states had a top 5 warmest year, and quite a few in our region: Illinois, Indiana, Kentucky, Michigan, Missouri, Ohio, Wisconsin. And for Michigan and Missouri, it was the 3rd warmest of all time, going back 129 years. And for Indiana, Kentucky, Ohio, and Wisconsin, it was the 4th warmest. You see on the map there the hottest areas of the country, the Deep South, the Northeast, but of course the Midwest, pretty much everything east was in the top 10, and no state was below average. So we were all warm for a number of reasons: climate change, El Nino, and we'll get into some of that. And if we look at precipitation, it was kind of a mixed bag. The far northeast, far west were relatively wet, and we had, but in most of our region, it was fairly dry, except for South Dakota, Michigan. They were more on the wet side, or very wet, but they're in the central part of our region, pretty dry. In the top 3rd driest, top quarter driest years. Now, if we dive into more detail, if we look at our region, the average temperature departure for last year was about 2 to 3 degrees, closer to 3 degrees over most of the region. and it was fairly uniform, pretty much anywhere east of the Rockies. If we look at precipitation departure from normal, we see fairly dry over much of the central region there, east of the Mississippi, west of the Missouri, a bit wetter. If we look at the percent of normal, we see Missouri, Iowa, some portions of the Midwest, Illinois, Indiana, Chicago, Kentucky, below normal, not terribly so, but you get out to, again, Iowa, Missouri, the heart of the drought areas, you're looking at 50 to 75% of normal, and that's for the entire year. So that definitely has an impact, and we'll see that when we look at the drought impacts. Now, you probably remember from last year, we had a number of what they call billion-dollar disasters in our region. I counted 11 in our states, but if you look nationwide, we set a record for the number of billion-dollar disasters for a year. And here's a list of through May of the ones impacting our area. Some of the higher value dollar disasters, a March 2nd, 3rd windstorm that moved across Kentucky and Indiana. That set some record low pressure values for, I think, Paducah, Louisville areas along the Ohio River. And that ended up causing $6 billion in damage. And near the end of the month, March 31st, April 1st, we had a fairly large tornado outbreak, over 30 tornadoes across those 5 states. And that caused nearly, $5.7 billion, 33 deaths from those. And I don't want to say your typical severe weather of the season, but we did start off with a pretty active spring. And then the latter half of the year, not quite as bad, but what caught my attention was this August 11th Minnesota hailstorm. So it's kind of unusual to see $1.8 billion caused in damages caused by a hailstorm. But that was confined mostly to Minnesota. It turned into a windstorm and moved into Wisconsin. But golf ball, the baseball size hail, tremendous amount of damage there. And then you see the last on the list, the April through September drought. They list 247 deaths. That's from the heat during that time, but $14.5 billion in damages from that. And some other memorable events, and I'll list these because they are climate related. Many of you may remember the death storm, and this is result from the drought going on at that time in that area. A 72 car pileup on a 2-mile stretch of I-55. And of course, who can forget our June wildfires from Canada? And that led to poor air quality across much of the Midwest. The air quality index, the AQI, was over 150 for a lot of those days, which is in the very unhealthy category. And finally, in Kentucky, we did set a new rainfall record for the state. We received over 11 inches of rain near Mayfield within a 24-hour period. And as many of us are seeing, we're seeing increased rainfall with a lot of these rain events. So now let's focus on last December, which is seems like a long time ago, but given the weather we've had recently. But when we look back at December, it was primarily mild and dry over much of the region. If we look at the statewide temperature rankings from last December, we see that a large portion of the upper Midwest experienced their warmest December ever. And we can probably attribute a lot of that to the strong El Nino ongoing, which again we'll talk about a little more later. But 11 states, so 7 states had their warmest December on record, all 7 of those in the upper Midwest, many of course in our region. And Iowa, Minnesota, Montana, North Dakota, South Dakota, Nebraska, and Wisconsin. And then you had 11 states that had their second warmest on record, many in the Northeast, but also in the upper Midwest, Michigan, Ohio, And then you had another 5 states that had their third warmest on record: Indiana, Illinois, Missouri, and a few others across the country. If you dive into the details of some of this, the numbers are pretty amazing, especially for Minnesota. They didn't have any below normal temperatures for either the Twin Cities or St. Cloud for the entire month. And when you look at the more detailed county breakdown, you see the heat was really centered in upper Minnesota and the Dakotas, where they saw a mean temperature of the month over 15 degrees. So 15 degrees above the average for those areas. But a large portion of the country above normal. And again, it's largely attributable to El Nino. Now, if we look at precipitation, we see, again, Minnesota is kind of the focus of attention. They had the wettest December on record, so they're the warmest and the wettest, and along with Delaware and New Jersey. And if you look at that county breakdown, the percent of average, you see quite a bit of rain across our region. For the month, we had 15 states in the top 10 that had the top 10 wettest Decembers on record. And South Dakota, Kansas also got in on the top 10 action there, but pretty wet across much of the plain states. You see Nebraska, Iowa, down into portions of Kansas. So fairly wet month for those areas. You see kind of 2 axes of precipitation, one in focused South Dakota to Minnesota, but kind of a second area going from roughly Amarillo up through towards Chicago. If you're in Wisconsin, Michigan, you kind of missed out on a lot of that. Wisconsin was above average, not by much. And Michigan, Ohio, below average, and then Kentucky and Indiana quite a bit below average. And if we look at again, a little more detail of the precipitation, you see kind of 2 focus areas, one in Minnesota to South Dakota, and then the second area, second region, roughly from, like I said, Amarillo, Dodge City over through northern Missouri and then up through Chicago. So 2 kind of axes of above normal precipitation, but then if you weren't in one of those 2 axis areas, then you missed out. If you're in North Dakota, Montana, or in Michigan, Wisconsin, or the southern half of Indiana, Illinois, Missouri, then you missed out on that precip. And if we look at snow totals, we see that fairly low snow totals in December across at least much of the region. If you were in Nebraska, North Dakota, you saw some, but it was still below average for them. So really across the region, it was a snow drought, particularly for areas in northern Minnesota, Wisconsin, Michigan, areas that for the tourism industry is pretty important for snow. And if you look at the percent of normal, you see just how dreadful that snowpack was across much of our region for December. And almost the whole region was less than 50% of normal, and in many regions below 25% of normal. So moving ahead to this month, fortunately things did change. And so I wanted to start off by, really we've had 2 different months within January. The first roughly 12, 13 days was before the Arctic event came down. And you see this is the departures from normal, really focused on Wisconsin. So if you were in Wisconsin or parts of Minnesota, you were 10 degrees or more above average compared to climatology for the first portion of January. And then if we extend that to include the Arctic outbreak week, then we see that most of the region is actually below average now for the month of January, except for Wisconsin and portions of Michigan and Minnesota, because they were so high, so much above average. This cold outbreak just hasn't push them below normal as yet, and it looks like they'll stay above average for the month. But you move west to the Dakotas, Nebraska, Kansas, and they're much below normal now, 8-10 degrees or more below average. So if we look at the minimums that we've seen over the last week and a half, pretty cold, and especially areas of Montana, the Dakotas, Wyoming, and you're looking at 20 and 30 below. These are low temperatures, air temperatures, not the wind chill. And for the rest of us, cold. In some cases, record-breaking. There was a total of 2,760 daily records broken. 72 all-time records were broken from this outbreak. Again, you see a lot of those records focused in Montana, Nebraska. Kansas had 8, but the cold air didn't quite have the impact as it moved east as it did areas in the northern plains. I thought this was pretty interesting. For those of us who didn't think it got too cold, it did get pretty cold in the Dakotas and Montana, portions of Nebraska, Kansas. The wind chills are pretty severe. And I've seen a few reports of farmers bringing their animals even inside their homes to get them out of this air. So I think 58 below is the coldest I could find, but you see quite a few below 50s, 50 and below. So you may be asking, well, is this the climatologically, if we pass the coldest temperatures yet of the season, climatologically? And I found this pretty interesting. So the further west you go, the earlier your coldest day of the year is. And for the Mountain West and areas further west, it's even in December. And then as you head east, it becomes later and later in the year. And by the time you get to Michigan and areas further to the northeast, it's next week or even at the end of this month. So it looks like for most of us on this call, this week or even last week was our climatologically coldest day of the year. So it's all uphill from here. So and looking at the forecast, it does look like a pretty quick warm up. So hopefully it doesn't stay there, but it does look like it'll warm up after this week. So again, looking at precipitation for this month so far, if you were again in this band of precipitation of snow, then you're one of the haves. But outside of that area, north or south, you're a have-not. Again, you have this rough axis from roughly Dodge City up through Chicago, and but north of there, Dakotas, parts of Minnesota, Wisconsin, you've missed out. And band roughly from Indianapolis to St. Louis and then further down in the Ozarks, so also kind of missed out on the precip so far. We'll see if that continues. And snowfall, again, it kind of fell in the same area. Again, if you didn't receive, if you weren't in that axis of heavier snowfall, then you missed out and got very little. Especially areas from Ohio, southern Illinois, Indiana, down into southern Missouri, along the Ohio River Valley. Very little snow down there, but then you had this pretty high axis covering Iowa, Nebraska, and Kansas, portions of Wisconsin. And there it is, a little more clear when you look at the percent of normal. And this is for the month. So we still have a lot of season to go. And this is the snow water equivalent as of yesterday. And again, you see Iowa really got hammered with and a lot of snow from this event, and portions of southern Wisconsin, portions of Michigan, and eastern Nebraska.
Hey, Jerry, can you
Yeah,
describe what snow water equivalent is real quick, please?
oh, that's the amount of water within your snowpack. So it's, yeah, if you melted it down, it's the amount that's left over. And how has this impacted frost depths between the cold air and the snow or lack of snow? And generally, the further north and west you go, the deeper the frost depth is. Not very deep in much of the rest of the upper Midwest. See pretty shallow depths there in Minnesota still, Iowa, Missouri. And but some of those regions now have a snowpack, so that'll keep it fairly well insulated. It's those areas that don't have as deep a snowpack, particularly in the maybe North Dakota and parts west, that you're seeing that really deep frost depths. But they've also been fairly warm up until recently. And so what has this done to our Great Lake ice? And up until this cold wave, the ice coverage was around 3%, which was among the lowest recorded. And but since that cold air intrusion has come through, you've seen pretty rapid growth. Just a few days ago, again, the ice cover was around 3%, and now it's 8% and still rising pretty quickly. But you see we have a long way to go to get to normal. Normal this time of year is about 25%. And not sure if we'll get that high given the forecast, but we'll see. On the bottom is just kind of interesting. It shows the percent coverage, the maximum percent coverage of ice over the Great Lakes going back to the 1970s. And you see here recently we've had quite a few years below average, last year being one of them. And so we'll see what it does this year. But pretty low numbers recently. And this is just a look at the individual lakes. Again, almost all the lakes were very, very low, below 5%, up until this cold air mass moves through. And you see, at least on the smaller lakes like Erie, you see pretty rapid growth in the ice coverage. Not much on Lake Ontario yet, but the cold air is just now making it there. You see Lake Michigan, some nice increase there. But we'll keep watching this over the next few weeks to see if that continues to improve. So what are some of the impacts from both the drought and the cold air? Quite a few headlines from last fall with the drought continuing in some areas through the winter. Just a couple of interesting headlines from Missouri. One city, I guess, was smelling a bad odor, and that resulted from the drought. Hay prices, depending on where you are, had some impacts from the drought. This is the Ozarks. Moving up to Nebraska, there's some areas of Nebraska are still dealing with drought. This is an example of a fairly large lake. They call it the Great Marsh. That's completely dried up. And quite a few cities now in Kentucky are starting to have issues. This is the driest it's been since 2012 in Kentucky. And so some cities haven't had to deal with low water for some time. We've had 3 cities declare states of emergency due to the low water. Now, this was before the recent rains, so this has improved, but still fairly low lake levels for them. And for areas to the north, again, areas pretty heavily dependent on winter weather for tourism. And this is an example from Wisconsin where they had to close festivals and because of the lack of snow and the warm weather that they've had. So so the lack of snow does have a lack of cold temperatures does have a financial impact for a lot of areas to the north. On the right, some areas of Indiana, we're seeing even some budding of various plants back in December, back when it was still warm. And but nothing to worry about yet. It sounds like from everything I've heard, the ag things are a little further along this time of year, and so it's not quite as damaging. Ice fishing turning deadly now is due to these warm temperatures. We're so used to going out and ice fishing, and we're so used to having cold temperatures that when we do have these record warm temperatures, and we still try to do what we're used to doing, and we can't. And so I guess quite a few examples now of people going out on ice that's just not thick enough, and getting injured or even dying from that. This was an example from Lake Mendota in Wisconsin. This was back on January 14th after the front had come through. The picture there shows some steam fog, but this was the third, maybe fourth latest freeze up in its 170-year-long record. So again, when you're used to going out doing things during the winter time on the ice, it can't come too soon. Getting that freeze up. So once that moved through, Iowa got, like I said, the brunt of the snow, or at least the center of the snowstorm that occurred. This was an example from an accident on I-80 that stuck traffic for 5 hours. This is January 9th. They hit snow even before the Arctic air moved in, but quite a few travel problems there, especially with all the politicians in town there. Caused quite the mess on the transportation. So many of you may have seen this. I thought it was pretty funny. This was the Kansas City Chiefs game. It was the fourth coldest game in NFL history, and kickoff had a temperature of -4 degrees with a wind chill in the -20s. And if you watch the game, you know that the coach's mustache was a focus of attention. It's all frozen up there by halftime, and remained frozen through the game. But pretty makes for interesting games when you're watching it from your warm home. This was interesting. At one point at 9:50 a.m. on January 12th, every state, all 50 states, had some type of NOAA warning or advisory or watch. And I doubt that occurs very frequently, but that just shows all the stuff that was going on with that Arctic air coming down and all that was going on at the time. And this is an example from Missouri. The rivers we did see quite a bit of ice form on the rivers, but a few ice jams, but not too much. There were a few instances of power generation plants that had to shut down due to low water levels, I believe on the Missouri, but those lasted less than a day. So overall, it didn't have too much of an impact, and not too many ice jams from this particular event. Nevertheless, schools and universities were closed nationwide. Some areas near the Quad Cities did receive 25 to 30 inches of snow. Moline, Illinois received over 25 inches, which was more than they had all of last year. The Chicago airport had 2 all-ground stop orders, and the second lasted for nearly 3 hours, which was pretty rare for them. And this was Chicago's most intense cold since 2019. With 30 straight hours below -5. And that's only happened 15 times, but it's the first time it's happened since 2014. And something that I haven't heard, but there were reports of, if I'm saying it right, cryoseism, which is when the ground freezes rapidly, it cracks and makes some terrible noises. And so the public was reporting instances of that. It can come across as it can sound like an earthquake with the ground creaking and making noise, but it's not seismic, it's simply the ground freezing. And something else I hadn't heard of, but it got so cold that they started lighting fires along the rail lines to keep that metal from warping. And so I don't know how many miles of track they light on fire, but this was near Chicago, and so these polar vortex events, these Arctic outbreaks, can definitely play havoc with transportation. So moving on to hydrology briefly. So this is the current drought monitor map as of this morning. And we have several pockets of drought. The most pronounced, of course, is this region across Kansas into Iowa and up through portions of Wisconsin and Minnesota. As everyone here knows, that the region's been under drought for quite some time now, and we've seen some improvement as of late, but it remains in D2, even some areas of D3 drought. And then we have some portions of central Missouri, and then up through central Indiana, southern Missouri, southern Illinois, and then a secondary area across the deep south up into Kentucky. Now, looking at last year, what did last year do for us? If you remember, this time last year, the plains areas were in drought, pretty serious drought. And last year saw quite a bit of improvement over most of the plains. Southern South Dakota, especially Nebraska, Kansas, Oklahoma, saw much needed improvement during the course of 2023. But areas east of the Missouri, areas of northern Minnesota, Wisconsin, Iowa, Missouri, saw quite a bit of degradation, and portions of the Ohio Valley. So what has this winter done for us? Well, looking at the last 10 weeks, going back to early November, we see that there has been some improvement, continued improvement across areas of Kansas, Nebraska, but northern Missouri. But that area of the lower Mississippi, Ohio Valley has been fairly dry still and is still in need of precipitation. But this is very typical El Nino, which in a typical El Nino, you have below normal precip in the Ohio Valley and warm temperatures to the north. And that is what we're seeing is in the Ohio Valley region in particular, very dry, and we'll see that in the outlooks coming up. If we look at the 7-day average stream flow, actually fairly good news. This time last month, it was pretty large areas in the lowest 25 percentile range. Now we're seeing even some pockets along the Ohio above the 75%, even 90 percentile range due to the recent rains. So good news for the Ohio, especially up near the mouth upstream in Ohio, Appalachia, and portions of the Mississippi as well. Missouri, not so much, still fairly dry streams in some areas of Missouri. Soil moisture, it's somewhat as you'd expect. Areas of drought have relatively low soil moisture still. Now the warm temperatures allowed some of that rainfall, recent rains, to be absorbed and not just be runoff, but and it looks like those soil temperatures will warm back up in the next several weeks. Satellite view of estimates of soil moisture, again, over large portions of upper plains, I wouldn't really, it's frozen, so this doesn't mean a whole lot, but in the warmer areas, especially in Indiana, southern Illinois, these areas do need the precipitation, and that shows up here in both of these anomaly maps. Now, how does that impact our rivers? Well, on the left are two gauges from the Mississippi, one from Minnesota, one from Tennessee, and the recent rains and precipitation have improved the water, the river levels, especially compared to where they were last fall. And both at throughout the river, it's increased somewhat and helped the transportation there. With the Ohio, the same thing.
Hey, Jerry. Hey,
yeah,
we're going to run out of time, so we're going to have to pick it up and get to the outlooks here pretty quick. So
Oh, okay.
Uh,
So good news on the rivers.
yeah.
And real quickly, snowpack, um, roughly running 50 to 60% of normal prior to this latest event. Hopefully that will go up now with the recent snows. This is the basin SWE estimates. Again, northern half still running roughly 50% or even below across Montana, the upper Missouri. Further south, it's a little bit better, 75%, and then in Colorado, quite a bit better, closer to normal, but still running really low in the Intermountain West. Now let's get to our outlooks very quickly. This is the 7-day QPF. Nice area of heavy precipitation coming in along the lower Mississippi up into the Ohio River Valley. Not as much as we need, but it's a good start. We'll see how far north some of this precipitation gets.
Sorry, Jerry. What does QPF mean, and what does that matter?
Oh, quantitative precipitation forecast. So this is how much rainfall we're predicted to get over the next week.
Next time, yeah. Thank you.
And if we look at the hazards outlook for that period of time, they are forecasting heavy rain across the deep south, but nothing making its way up into our region. If we look at the 8 to 14 day outlook, it's very, at least temperature wise, it's very El Nino-like, predicting warmer temperatures, especially in areas to the north. Again, focused on the upper Midwest, Wisconsin, Minnesota, Michigan. And the nice thing is the 8 to 14 day has this area of precip moving up, and which will help a lot of those drought areas. Now, the bad news is that our month outlook for February is, again, very El Nino-like, which means warm temperatures to the north and very dry areas in the Ohio River Valley and areas north. So that's not necessarily what we want to see. If we look at the El Nino outlook, we see that El Nino is predicted to continue and probably peak in the next month or so, if it hasn't already. And so, and after that, it's forecast to fade into more neutral conditions by the summer. And then later by the fall, they're forecasting, at this time at least, a La Niña to develop. So a lot of the 1 month to 3 month forecast is really driven by this El Nino, the strong El Nino that we're currently in. And if we go to that 3 month outlook, we do see indeed that this is what you'd expect from El Nino, and that's what's largely driving this outlook. Warm temperatures to the north, especially over our region, and below normal precipitation across the upper Ohio Valley, upper Midwest, with above average precip over the plains. And if we look at the drought outlook, we see continued drought in areas of the Ohio River Valley, Tennessee Valley, but an improvement over the plains, an improvement over Kansas, Nebraska, not so much over, say, Iowa and points north from there. So just to recap, 2023 was the warmest year on record globally. In the U.S., it was in the top 5. And we saw improved precip conditions across the plains, but drying across the areas to the east, especially Mississippi, Ohio River valleys. And so far, the first half of the winter was very typical El Nino, with warm across the northern tier and dry conditions across the Ohio Valley. Very much what we would expect. And, looking ahead, it does look like a return to very typical El Nino conditions with warm temperatures across the north and areas to the east dry. And seasonally looking ahead, we do expect this transition to neutral conditions as we move towards the summer with developing La Niña in the fall. And kind of the big questions now, will El Nino precipitation patterns return, or will spring rains and ground recharge return in time for agricultural spring planting, and what exactly will be the timing of that El Nino transition. Will it happen faster, allowing the rains to return, or will it kind of delay and keep us dry? So with that, I'll stop. And if you do have any questions for Dennis or Doug, feel free to email them or call them there. And if you'd like more information, you can go to these websites. And if you're interested in any past recorded presentations, again, those are available. So with that, I'll stop and we can take questions.
You bet. Thank you very much, Jerry. That was as complete as you could do it in that much time. So appreciate that. We always have too much to talk about and limited time to do it. So let me get to the questions real quick. I'm going to sort of start at the bottom and go up. Analog years to rapid transition from El Nino to La Niña. La Niña usually correlates with dryness during a critical time in the growing season. It's the comment. It's not me. That's the comment. So, yeah, there are a lot of analog years. There's a tendency to see fast transition from stronger El Niños than we'll say marginal or weaker ones. But this is a little unusual in that we were last year in a La Niña at this time, and it kind of lasted into the spring pretty far, and then sort of stopped, and we shifted back to neutral for a very short time, and very quickly became a long-lasting and very strong, relatively strong El Nino. So the fact that we're shifting back or may shift back this spring, again, relatively rapidly to at least neutral, and really the jury is still out on the La Nina. It's quite possible it'll happen, but it's not a for sure bet, right? So we have to say these things with probabilities involved. So there's a stronger probability right now that we'll see a La Nina next fall, and you can see that it sort of gets going in the month or in the summer. Okay, so we'll definitely watch for that, but probably won't be super conclusive on that until June, July. That's normal. It'd be unnormal to see it really shoot up or become much colder, which really rapidly, but it could happen. Anything else you want to add to that, Jerry or Dennis?
Doug, when you said it will get colder, were you referring to the sea surface temperatures getting colder?
Yeah, I'm sorry. Yeah, sea surface temperatures being La Nina, the La Nina phase, cooler equatorial temperatures. Yes. And so the other question somebody asked was, when is La Nina supposed to kick in? Well, generally, late summer is when we get a real good kick, but sometimes before that too, we can tell. At some point, I should say. Okay, snow coverage was also low in 2012. Heat was excessive, that is true, during the winter months, especially in March, if people remember. Are there any other similarities to 2012 or any other year? Dennis or Jerry, do you want to expand on that?
Ooh.
Well, why don't we start with Dennis? Why don't you talk a little bit about 2012 and how this is different than that? Because we definitely didn't have the Arctic outbreak that we've had.
No, we didn't, and we didn't have any big Arctic outbreaks that year. I can't remember the winter as a whole, but definitely the latter part of the winter was quite warm, and there was a lot of warmth early in the spring. And you also have to remember that 2012 came out of the 2011 floods, so it was really interesting that we were actually kind of wet in 2010-11 and had the big 2011 flood on the Missouri River. But then we really kind of turned dry starting the middle of 2011 that carried over into 2012. I have to, per this idea of transitions to La Nina, I have to go back. There were a couple of the drought years where we transitioned into those, but I don't think we can use that and say drought is more likely this summer because of the impending shift to La Nina. Doug was right. It's something we will have to watch.
And the other thing is, we don't, that transition, so there's a lag between, there's a giant or a big lag, I don't know how many months or weeks, but there's a big lag between what happens in the ocean and what happens in the atmosphere often. So the atmosphere may continue to reflect El Nino conditions. I'm just guessing here, but could reflect into May and June. And then we start getting more neutral conditions, and then sort of the jury's out on making long-term predictions like that.
Mhm.
I will. We have a question someone asked earlier about can we blame inflation? Remember, Jerry showed a lot of stuff on billion-dollar disasters, and basically the question was, is it inflation adjusted? And yes, it is inflation adjusted back to 1980 when they started the billion-dollar disaster collection, I guess you could say. So yeah, we're not having more billion-dollar disasters because everything costs more. It is inflation adjusted. How about that? What were the impacts to wheat? Dennis, I think you might want to talk about that real quick from this winter outbreak, if any.
Right. And the thing I didn't include in the answer online was about snow cover. Some of the areas of winter wheat did have some snow cover on them. That's a good thing. It will protect them. Some of the areas further south did not have snow cover, but they don't commonly have snow cover. So we did not hear any comments from anyone about concerns on winter wheat. It probably did get dinged a little bit, but winter wheat has this ability to deal with, several different impacts and still come out okay. So I think in a larger context, I don't think it's a major issue, but probably should ask a couple more questions about that just to make sure.
Yeah, stay tuned for next month.
The one graphic I have seen from the USDA on the winter wheat showed it as being fairly good so far for the season compared to the last several years.
Okay.
So we'll see.
Quite a few comments. My good friend up in Montana is suffering from very cold temperatures, winds, broken pipes, sewer and gas lines, etc. I'm sorry you have to go through that up there in Montana. It was one for the records in terms of cold air outbreaks. And we'll get to a little bit more of that discussion. There was a question about soil moisture anomaly calculations. I think Dennis provided a link if you want to understand that better. But Dennis, do you want to talk a little bit about soil moisture generally this time of year? Very generally, not about any particular model, if you want, but I hate to say accuracy, but the usefulness of those maps.
Well, I mean, it's as useful as what we have regionally overall. The thing we're watching is we know that a large number of places large number of our whole region. Northern Plains has done better. Iowa specifically, and then parts of the Eastern Corn Belt typically are drier heading into the winter because most of their soil moisture has been tapped out during the growing season. Especially in Iowa, we did not get much in the way of fall rainfalls except for the north. So we have some very dry soils. The warmth early in the winter kept a lot of soils from being frozen. So the winter rainfall, the Christmas rainfall didn't go in soil moisture. That's a benefit. There was a comment there about some of the early snowfalls still fell on unfrozen soil. So a little bit will melt and go in there. But as we're getting soil starting to freeze up, we're not going to add much more moisture to the soil at this point. So we'll need more come springtime to be able to refill that soil moisture profile as much as we're going to be able to. We're not going to get that soil moisture profile refilled in a chunk of places simply because there's too much water we need to add.
Right, and snow is not always the best, although it can melt slowly and can infiltrate over time. It takes a heck of a lot of snow to equal a good thunderstorm.
And even if you do have unfrozen soils and you melt snow, a chunk of that is still going to run off, which helps our drought situation from a runoff standpoint, doesn't help our soil moisture as much.
Yes, longer term question, but it's good polar vortex question, I guess you could say. Longer term question, what are we expecting in terms of polar vortexes and increasing impacts of climate change in the future? Are there projections for their frequency? So I'm going to start by saying this is still up for debate, but there is a school of thought that believes that such vortexes will become more common, and we'll see more Arctic air spillage due to weakness in what keeps the vortex in the Arctic. Is probably the best way to say that. So there are winds circulating at various levels of the atmosphere, more or less pinning that Arctic air to the Arctic. When those winds weaken around the globe, or around the Arctic really, it allows spillage of that cold air south. Where that happens, we don't always know, but it's not just that. And there are several other things like snow coverage and other issues that can cause those things to happen. But the weakening of some of the winds that confine the Arctic air to the Arctic, which we've seen lately, allow that spillage, like we saw in 21, way down into Texas, if you remember correct. Remember that situation. Anything else on that, anybody? And then there was someone pointed out from Kentucky that 2011, if people remember back, 2011 was the wettest year on record in portions of Kentucky, and the driest in 2012 on record. So yeah. There's more questions here. Will corn and soybean planting decisions be influenced by dry soil moisture conditions? That's not me.
I'll take that, Doug.
Yes, please.
Honestly, dry soil moisture conditions may encourage more planting, because people are able to get out more easily and get things in the ground. And as long as crop insurance is there to support it, then they're willing to take that risk, because part of that risk is covered by crop insurance. What people should probably be doing is looking at where their soil moisture is and maybe go ahead and plant, but be careful about their yield goals, what their projected yield is, and fertilize appropriately. That if you're going to be short of soil moisture, maybe you don't aim for top yields, because you're probably not going to be able to get it. Those are the kind of decisions we may see people make. But unless soil is incredibly dry, people are probably going to mostly go ahead and plant what they're going to do. They might change populations a little bit.
Basically a comment that we are in uncharted ground for prediction because we haven't seen these changes before. I wouldn't say that's the case. I think that if you want to talk about how climate change has affected certain things, you might say that, especially for the warmer temperatures, that it's added X degrees to whatever was already going to happen. So if we're going to have a heat wave and it was going to be 100 degrees, and that, sort of pre-human, now it's 101 or 102 or even more. But what I'm saying is it's sort of icing on the cake for the most part. Now there are some extremes that are happening that, or changes in the climate realm that we're not used to seeing very often. I wouldn't necessarily say we've had Arctic outbreaks forever. We just don't have them as often. As maybe we have in the past. And even during an El Nino, when it's supposed to be, I put that in quotes, relatively warm to the north and relatively cool to the south, you can still have them, as we've seen. So, yeah. Yeah, I'm not going to go into that too far. And then the last question I have on here, when it says calculated soil moisture map, are they actually digging the soil up and processing it for moisture content? And if not, is there some ground proofing of the data? That's a great question. Great question. Dennis, do you want to start that and I'll finish it, or you want to finish it?
In most cases, there is no soil that is being dug. On the maps that we show, it is usually modeled where you take inputs of precipitation and outputs of water loss through the soil or evapotranspiration. So it is a gross assessment and usually in the ballpark of what is happening. There are stations that measure, that have sensors in the ground. The hard part is getting a wide range of those areas. Actually, Jerry works on a mesonet. He could talk about this down in Kentucky and what they do. You know, the going out and actually measuring soils and drying it out. Actually, some people in Northwest Iowa, extension people in Northwest Iowa, do that a couple times a year, spring and fall, to get a handle on it. But it's a tough thing to try to do. I don't know, Jerry, do you want to fill in on what you folks do there?
Well, you described it well, and a lot of the mesonets across the country are adding soil moisture sensors if they haven't already, and a lot of those sensors send out either an electric pulse or a little heat element, and they estimate the moisture from that heating return or that electromagnetic radiation that's received back. So most use some kind of proxy sensor, but the gravimetric sampling that you describe is again used usually a couple of times a year or occasionally to calibrate those reference sensors. But it's rare that you actually go out and dig up a sample and test it, just because of the work involved.
Thus, what you see on these maps are heavily modeled. Again, Dennis said grossly accurate, which may sound like an oxymoron type of thing to say.
Well, we certainly don't want to say inaccurate, though we did have a problem with one of the models last winter where there was some bad data going into it. So it was clearly inaccurate, but we weren't sure what was going on. Fortunately, they got it solved.
Yep. And on that note, I think we are done. And I want to thank everybody who participated and asked questions, especially Dennis likes answering lots of questions. So I say thank you very much. And next month, we'll have our representative from, I'm sorry, our state climate office from Kansas do the presentation. So anyway, thank you all. Have a great rest of January and early February.
Thanks, Doug. Thank you.
Thanks, Jerry.
Thanks, Dennis.
Thanks, Jerry.